Hello everyone. In this video I am going to explain the concept of solving direct proportion related questions step by step. In the previous video on the direct proportion topic, I explained what is the meaning of direct proportion, how to represent it graphically, and how to write that the one quantity is proportional to the other. We learned about the basic things related to direct proportion. In today's lesson, in this video I am going to focus more on solving the questions which are based on the direct proportion. All these questions are from the GCSE exam question practice papers. So the first question here is, a ball is dropped from a tower at after t seconds the ball has fallen a distance of x meters. It is like a ball is fallen from the tower, something like this. This is a tower and from here the ball is fallen down. It's not required to draw the diagram, I just show it to you. Okay, this is just for like understanding. So after t seconds the ball has fallen a distance of x meters. So let's say t is 2 seconds and this distance has been covered here f to x meters for a distance of t seconds. I don't take a particular value, just for t seconds. It can be 2 seconds, it can be 4 seconds, depends upon the question. So here what they say, x is directly proportional to t square. So the distance which is covered by falling the ball, that is directly proportional to t square. So this is a way to write. Now this is the first thing. Now we have to convert it into an equation, a rule which will connect our these two variables, time and the distance covered by the ball. So I will be using a constant of proportionality k, and this will be my first equation. Now they say when t is 2, x is 19.6. So x is 19.6 when t is 2. So I will substitute it. I will substitute these values here. So what I am gonna get is 4k is equal to 19.6, or k is equals to 19.6 divided by 4, which is 4.9. okay, so I can say my equation will be now x is equal to 4.9 t square. This is my first equation, and they asked us in the first part find an equation which will connect x and t. So I got this one, that x is equals to 4.9 t squared. So that is the first part of this question. Now the second part of this question is, find the value of find the value of x when t is 3. Now once you have got this equation which is given here, like connecting x and t, after that you just need to do the substitution. So we know that x is equals to 4.9 t squared, and they said what is x when t is 3. So after 3 seconds how much distance will be covered? So I will plug in the value of t as 3. So it will be 3 square, which is 4.9 times 9, and that will come out as 44.1. and because it is a distance, so we will consider it in meters, as it is given here meters. Distance is given in meters, so we have to use meters. Next question is, again I will be writing my rule or my equation, that x is 4.9 t square. The question is how long the ball takes to fall 10 meter. So 10 meter distance we have to cover. How much will be the time will be required? So now time is needed, so I will use the t variable as it is, and x is 10 meters. So t square is equals to 10 over 4.9, or I can say it is 100 over 49. So t square is 100 over 49, and t will be equals to plus minus square root of 100 over 49, because this is a time, it cannot be negative, so we will say reject the negative sign. Okay, normally what happens, whenever we take a square root we always take plus and minus sign, but here t is representing time and it can't be negative, so this is 10 over 7. So I will say 10 over 7, or which is equals to 1 and 3/7 of seconds. So this will be the answer for the third part of this question. Now let's go to the next question. Again, I am focusing only on the questions which are related to the direct proportion. Second question says here that the amount of petrol a car uses is directly proportional to the distance it travels. As much as petrol will be there, that much distance it would be able to travel. So we can say petrol, amount of petrol. So let's say P is representing the amount of petrol. It is directly proportional to the distance. So S is representing the distance and amount of petrol I am showing with the letter P. And it is directly proportional to the distance, no square, no cube, so just P is proportional to S. And then I will write P is equals to Ks, where K is the constant of proportionality. And the second thing, some information is given in order to find out this K. They say a car uses 3 liters of petrol when it travels 50 kilometers. So how much petrol? 3 liters when it travels 50 kilometers. So K is equals to 3 over 50. So my equation now will become, if I write the equation, so it will be P is equals to 3 over 50 times by S. You can convert this 3 over 50 into decimals also, it is up to you, but as they haven't said anything, so we are free to choose. If you want to use that way, so P will be equals to 0.06 times S. Let me rewrite it in a better way. So I can write P is equals to 0.06 S. This is a rule which is connecting P and S. Now the first question is, work out the amount of petrol car uses when it travels 125 kilometers. This 125 kilometers is a distance. So P is equal to, this is the answer for the first part. So P is equal to 0.06 and distance is 125. So I will times these two values, 0.06 and 125, and it will come out as 7.5 liters. So how much petrol will be required? 7.5 liters. And the next question is, how much distance it will travel when it uses 5.7 liters of petrol. So again the equation is given as P is equals to 0.06 times by S, and if petrol is given as 5.7, so 5.7 is 0.06 times S, and from here I have to divide 5.7 by 0.06. So I will be writing 5.7 over 0.06 is S, and that will come out as 95 kilometers. So this completes the question. Next question is, M is directly proportional to P cubed. So here is M a variable and it is directly proportional to P cubed. So next step will be removing this proportionality sign and using a constant of proportionality, where K is the constant of proportionality. If you see, there are simple steps. You just need to focus. We have to find first the equation by getting the value of K, and then find M if P is given, and if another variable P is given, and we have to find it like that way. Variables can be anything. Now they say M is 128 when P is 8. So it will be 8 cubed. So K will be 128 over 8 cubed. And if I solve this part, 128 divided by 8 cubed. So 8 cubed means it will be 512. So if I divide it by 512, I will be getting it as 1 over 4, 0.25. So I can say M is equal to 0.25 P cube. This is a formula which is connecting M and P. Then the next question is, we have to find the value of M when P is 5. So M we have to find out, and M is 0.25 P cubed. So it is 0.25 times 5 cubed. So it is 0.25 times 125, and this will be 0.25 times 125. It is gonna be 31.25. So I will say the answer is 31.25. Now one more question. A particle moves from rest. That means when t will be 0, the velocity or the speed will also be 0. See, sometimes values are not given directly, but we need to understand. A particle moves from rest. The speed of the particle is v meter per second when it has moved a distance of x meters, and v is proportional to square root of x. So v is proportional to square root of x, and I can say v is equals to k times square root of x. Now to find out v in terms of x, they said v is 8 when x is 25. So square root of 25, which means k is equals to 8 over 5. So this is equals to 1.6. So v is equals to 1.6 times square root of x. This is the first part. Next is find the speed of object when it has moved a distance of 56.25 meters. So the first thing is, I will be writing the rule that v is 1.6 times square root of x. Now I can replace the square root of x by square root of 56.25, and if I find this value 56.25 and I times it by I have to times it by 1.6. So this velocity or the speed, it will come out as 12, and the unit will be here 12 meter per second. So this will be the answer. I have covered some of the parts of this worksheet. There are a lot of questions, but I hope you have got an idea now. Some of the questions will be based on the inverse proportional also, and that we will be discussing in our next video. So keep watching. Thank you.